Good morning, students. We are looking at the topic Basic Geometric Theorems. Basic Geometric Theorems, Part 1. That is, triangles and polygons. So I want you to open to your new concept, Mathematics, Chapter 13, page 156. At the end of this lesson, you should be able to write out formal proofs of some basic theorems in plane geometry. Prove some of these basic theorems. Apply the theorems in solving practical problems involving geometry. Before we go deeply into the lesson, there are some keywords that you need to be familiar with. The first one is proof. Proof is a logical statement using evidence to establish a fact, hypothesis, or an argument put forward. Theorem is a general conclusion in science or mathematics which makes assumptions in order to explain some basic observations. General conclusion in the sense that it has been proven to be true, fact, therefore it is generally acceptable. Geometry is a branch of mathematics that deals with the properties of shapes. Before we carry out the actual theorems, there are elementary theorems that will help us to arrive at the logical conclusion. First one is that vertically opposite angles are equal. This diagram here shows you what vertically opposite angle is all about. You can see two straight lines that intersect. From there we obtain vertically opposite angle. In that diagram, angle A is equal to B and X is equal to Y, meaning that A is vertically opposite to B and X is vertically opposite to Y. Do not be confused with B and Y or A and X. They are not vertically opposite angles. They are merely on the same straight line. Another one is that corresponding angles are equal. If you look at the diagram, you see two parallel lines, that lines with arrow, and you see the angles, and there's another line that cuts the two parallels. This line that cuts the two parallels is known as transversal. This is the line I'm referring to. That is a transversal. So angle A corresponds to angle B. Therefore, they are equal. Correspond in the sense that they are in similar locations or similar positions, but different parallels. Okay? A is equal to B. Then another one is that alternate angles are equal. In this diagram, X is on the alternate side of the transversal, and the same thing is applicable to Y. So we say that X and Y are equal. If you don't call it alternate angle, you can call it the Z angles. Then theorem number 1 that we are going to prove today says that the sum of angles of a triangle is 180 degrees. We are going to prove that the sum of angles of a triangle is 180 degrees. This is the figure that will help us to carry out the proof. Okay? For you to carry out a proof, you can see that 4 steps that is listed out. Number 1 is given. Number 2 is to prove. Number 3 is construction. And finally, the proof. So we are given triangle PQR. Okay? We are given triangle PQR. And we are to prove that angle PQR will give us what? 180 degrees. This is the angle at P, this is the one at Q, and this is the angle at R. We want to prove that angle at P, the one at Q, and the one at R will give us what? 180 degrees. Okay? So what do we do? For us to carry out the proof successfully, we now construct. You can see the line QR is extended to point T, and R is extended to what? S. The line RS is drawn in such a way that it is parallel to PQ. Okay? They are parallel to each other, meaning that they can never meet each other, they can never intersect, no matter how you extend it. So let us go into the proof now. With the lettering in this figure now, you can agree with me that Q1 is equal to Q2, meaning that they are corresponding angles. Okay? We already know what corresponding angle is all about. Okay? We have that Q1 is equal to Q2, corresponding angles, and P1 is equal to P2. They are alternate angles. Okay? So, let us make progress. We use what we already know to carry out the proof. We already know that angle on a straight line will give us 180. So that is why we sum up the angle on this straight line. You need to change this capital letter R to small letter r, so that we have R plus P2 plus Q2. Also change this Q2 to small letter q2, as you can see on that straight line. That will give us 180 degrees. Hence, R plus P1 plus Q1 is equal to 180 degrees. This is where I'm referring to. Why do we have that? We have replaced P2 and Q2 with what? P1 and Q1, since they are the same. Okay? With that, we can conclude that angle at P, angle at Q, and angle at R give us what? 180 degrees as required. Okay? That is how to go about that. We have been able to carry out the proof successfully. Take a closer look at it. Okay. Now let's look at this example 1. In this example, angle P is the unknown angle in that diagram. So how do we find that unknown angle? We add P plus 62 degrees plus 51 degrees, and that will give us what? 180 degrees. Okay, because angles in a triangle is what? 180 degrees. So we have P plus 113, that's the sum of 62 plus 51, is equal to 180 degrees. When you rearrange, P is equal to 180 degrees minus 113. Of course, you know that when a positive sign crosses equality sign, it will change to negative. That's why 113 degrees is changing to what? Negative on the right hand side of the equation. From there we have P to be what? 67 degrees. In this example too, the angles of a triangle are 2x, 3x, and 4x. Find the value of x in degrees. Okay, this is the solution. We will now sum up everything and equate it to 180 degrees. Look at it here. We sum up 2x, 3x, 4x, and we have what? 180 degrees. When you add 2, 3, 4, it gives you what? 9x. And you equate it to 180 degrees. Now, to get the final answer, you divide both sides of the equation by the coefficient of x, that is 9. And when 1 is done, you have what? X is 20 degrees. X is 20 degrees. Theorem number 2 states that an exterior angle of a triangle is equal to the sum of the opposite interior angles. An exterior angle of a triangle is equal to the sum of the opposite interior angles. In this triangle that you see here, angle P2 is the exterior angle. And this theorem says that the sum of P1 and Q1 will give us what? P2. Of course, that is what we are going to prove. Now look at it. We have that R plus P2 is 180 degrees. That is angle on a straight line. Okay? We've known that angle on a straight line, this is a straight line, is 180 degrees. Again, R plus P1 plus Q1 is equal to 180 degrees. Sum of angles in a triangle. Okay? Now, you can see that the first expression and the second one, they are all equal to what? 180 degrees. By implication, you can equate the two expressions. And when you equate them, this is what you have. Okay? Having done that, how do you arrive at the final answer? You subtract R from both sides of the equation. When you take away R here and also take it away from here, you can see that P2 is equal to P1 plus Q1. Okay? You can see that P2 is equal to P1 plus Q1 as required. As required. That's the solution. With that now, we have been able to prove that the exterior angle of a triangle here is equal to the sum of the opposite interior angles. Okay, take a closer look at that. Then let's look at this example 3. Find the size of each marked angle in figure 1.1 shown below. Okay, that is the figure we are going to work on. Solution. We apply the concept of corresponding angles. Angle D corresponds to what? Angle 65 degrees. Since they are in similar positions but different parallels. Okay. Now, from the theorem that we've just stated, this angle here, F and D, gives us the exterior angle, that is 132 degrees. Okay, it gives us 132 degrees. So what do? You substitute the value of D, that is 65 degrees. How do you get expression for F? You rearrange by subtracting 65 from both sides of the equation. Okay, you can see that, and from that, F is equal to 67 degrees. Okay, now for us to find G, we will use the concept of angle on a straight line. Okay, angle on a straight line. You see 65, G and F, they are on a straight line. Okay, so you substitute the values for F, that is 67. Okay, 67. Okay, you can see that 180 minus the sum of 65 and 67 will give us what? 48 degrees. That is the value of G. One more thing that we want to find is angle E. You can see that angle E is alternate to G. So G is equal to E. They are alternate angles. From there we say that E is equal to 48 degrees. Okay, let's quickly look at Pythagoras theorem. Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This is a right angle triangle we are talking about. And let me show you the hypotenuse. This side that is opposite the 90 degrees, where you have small letter b, that is from A to C, is the hypotenuse. It's always the longest side of right angle triangle. So when you are applying Pythagoras theorem, it is advisable to first of all square the hypotenuse before you equate it to sum of the squares on the other two sides. Now this side A and small letter c, they are adjacent to angle 90 that you see there. Okay, so let's take example. Find the value of the missing side of the triangle. If you look at the diagram, we have two right angle triangles. The first one is ADB, and the second one is what? Can you identify it? The second one is AB and C. Okay, so we are going to start from ABD. We are starting from ABD. So what do you have? 13 square is equal to B square plus 5 square. Okay, when you rearrange, making B square the subject, that is why you have b square is equal to 13 square minus 5 square. Square of 13 is 69 minus square of 5 25. When you subtract that, you have 144 cm square, and then b is equal to the square root of 44, and that is what? 12 cm. We've gotten expression for b. Then we want to find what? A. A is the distance from C to D. But before we do that, we need to find x. By finding x, we are considering what? The triangle. We are considering triangle ABC. So you see that 15 square is equal to what? B square plus x square. When you now make x square the subject of formula, you have 15 square minus 12 square, and that will give us what? 81 cm square. For you to find x, you take the square root of both sides. Square root of x square is x, and square root of 81, of course, you know, is what? 9 cm. But A is what? 9 minus 5. You know, we are looking at this place. So since the entire dimension is 9, we now take away 5 from 9 to have what? 4. Okay? This is assignment for you. That's assignment. Now, for questions and comments, send it to SS1@brightfuturecollege.com. Thank you.